Welcome to Chamford. I'm Chesal, and here we discuss all things 3D printing. I did a video a while ago on this DC connector that uses magnets. It worked for a while, but the solder joint failed. Solder joints are not the best for applications where there's a constant vibration, and this is exactly that application. Plus, these magnets lose strength when they're heated, so that's another reason to not solder wires directly to them. So in this video, we'll make version 2. Yeah, I'm going to walk you through the design that I have. I'm going to keep it simple. I've kept most of the design considerations from version 1, and this is only a slight revision to the first one. So just like the first one, the female piece gets screwed down to the underside of the desk. That's what these screw holes are for on either end. And there's a little recess in the middle for the male piece to go in. And there's a single magnet that's not exposed. It's right here. It's embedded 0.4 millimeters in. So if we dissect it and go in, this is a cavity for the magnet. A single magnet is strong enough to keep the contacts tight, so that's not really an issue. However, now that there's only one polarity on the face, we can mix up the positive and negative terminals. So I've created this little key off to the side to ensure the correct orientation. And just to show, there's the matching groove on the male piece. For the contacts themselves, I'm thinking of using some copper strips that are 0.1 millimeters thick. So I'm going to print a little square block or rectangular block that fits inside this cavity with a little bit of tolerance, of course, and wrap that block with copper strip. And I'll be soldering the wires to the copper and jam the whole assembly in the hole. And I'm thinking if I get the tolerances just right, there will be enough friction that I probably won't need to use any glue. All right, so that's the plan. Let's get to printing. All right, the print came out pretty good. I've embedded the magnets already as part of the print, and yeah, there's a very satisfying click. So that's all as expected. Pretty happy with that. And the next step is to install the conductors. So yeah, if you've been here before, this is my copper strip that I like to use in every video pretty much. And like I said, it's 0.1 millimeters thick if I remember correctly. It's 5 millimeters, I believe, this way. Let's make sure. Yep, that's 5 mil. The hole's a little small, but I can use a pair of scissors to make that work. I ended up switching to a 2-magnet design. You notice the gap is a little wider now. The rest of the design is pretty similar though. And here, one thing I've changed on the male piece is that I've added this strain relief. It wasn't really a problem before. This is more of an aesthetic change, which makes it nicer to grip and nicer to look at as well. Here you can see those are the copper contacts. The contacts are about, I want to say, 0.5 millimeter proud of the rest of the surface. So all the contacts are a little proud, so they make good contact. Hopefully the camera is able to pick up, but here's a look from the back where I jammed the cables in, and I used a little bit of thread locker to secure everything. I originally wanted to use hot glue in there, but hot glue is way too thick for that small space, so it doesn't want to flow in there. So I've opted to use thread locker instead. So the connection is pretty good. I've been testing a bunch, and I can yank on the cable. I can wiggle it up and down, left to right. And how I have been testing is I have this USB meter which I plug in here and plug the other end into the power source, and I basically have been watching the screen here while I was wiggling, pulling, yanking, and all that. Right, so I guess that marks the end of the video. I want to thank you for watching. I hope you got something out of it. I'll see you next time. Thanks. Bye.